Hello students, in today's lecture I'll take the unsolved problems of chapter 5 of the chapter Sound and Doppler Effect. So in which the first problem is calculate the change in intensity level when the intensity of sound increases by 10 times the original intensity. Okay, so in this, what is the formula to find out this change in intensity level? The formula is intensity level is equal to 10 log to the base 10 I by I0. Okay, and what they say that I by I0 is given out to be 10, or I is 10 times I0. Okay, substitute the value over here, so you get 10 log to the base 10 I by I0 is 10. Okay, so as simple, 10 log of 10 to the base 10 will be 1, so answer will be 10 dB. It is that simple, right? So in the MCQ you might ask the same question with different options like 10, 20, 15, 25 and so on. So 10 is the correct answer. Okay, same logic is used in the next problem also. Calculate the change in intensity level when the intensity of sound increases by 10 to the power 6 times its original intensity. So in this case, what is given? I by I0 is 10 to the power 6. So intensity level IL is equal to 10 log of I by I0 will become 10 log to the base 10, 10 to the power 6. So this is nothing but 10 into 6 into log of 10 to the base 10. So this is 60 dB because log 10 to the base 10 will be 1. So this is the way we will be solving the further problems also. Now the third problem is a hall of capacity 56 into 10 to the power 3 or 56,000 cubic feet is found to have a reverberation time of 2 seconds if area of sound absorbing is 7,000 square feet. Calculate the absorption coefficient. That's the question asked. So the formula I taught you is reverberation time T is equal to 0.05 V divided by A. Fine. Now in this case, what reverberation time is given to you, V is given to you, and what is this A? This capital A is nothing but S into small a. What is S over here? Is the actual area, and this small a is absorption coefficient. So we need to find out the absorption coefficient over here. Okay, so we'll solve this. How much is T given to you? T is 2 seconds. So 2 seconds is equal to 0.05 into V. What is V? 56 into 10 to the power 3, yeah, 56,000 divided by A, as I mentioned, A into S. S, how much they say? 7,000. So I'll say 7,000 times A. Okay, so if this you need to simplify. So this will become how much? A has to be 0.05 into 56,000 divided by 2 into 7,000. So this you have to solve and get the answer. So if you cancel this, okay, so 0.05 into 56 divided by 14 gives you exactly 0.2. So the answer for the absorption coefficient turned out to be only 0.2. So the problem will be the absorption coefficient will, they might give you the options MCQ 0.1, 0.5, 0.15 and 0.2. Okay, so this is the way we can solve it. Now the next question. Next question say a classroom has dimension 20 by 15 into 5 meter cube, means 20 meter into 15 meter into 5 meter. Okay, the reverberation time is 3.5 seconds, little high, but it is given. So calculate the total absorption of the surface. That's what is the question given to you. Okay, so same thing. What is the value now? The values are given in this case in meter, not in cubic feet. Okay, so the formula to solve this will be T is equal to 0.161 into V by A. Fine. Okay, what you need to find? Total absorption you need to find. So is T given to you? Yes, T is given to you. Is V given to you? Yes. And we need to find out A. Okay, so we can say therefore 3.5 is my reverberation time. 0.161 into volume. How much is volume? 20 into 15 into 5 divided by A. A we do not know. So therefore we can say A will be 0.161 into 20 into 15 into 5 divided by how much? 3.5. Because 3.5. So if you simplify this, okay, little more carefully, you will get the answer for A to be 69. Check this out. Okay. So again here the MCQ will be, the answer will be close by, but you need to be very careful with the calculation. So a calculator is allowed, so do it and try to get the exact answer. So this is the way you will be solving the questions for MCQ in the examination. Okay, we'll move to the question number 5 now. Next, question number 5. A spectral line of wavelength 6000 angstrom unit in the spectrum of a star is found to be displayed from its normal position towards red end by 1 angstrom unit. Calculate the velocity of star and the sense or the direction of the motion. So now in this case we will be using the formula what is called as d lambda is equal to Cs upon C into lambda. Okay, what is given to you? Given to you is d lambda. How much is the shift? Is 1 angstrom unit. And how much is lambda given to you? It is 6000 angstrom unit. Fine. Now value of C is obviously known to us. Okay, so our job is to find out basically Cs. Okay, so now we can say therefore CD lambda is Cs into lambda. Okay, I do not know Cs, so I'll say Cs is equal to CD lambda divided by lambda. Okay, now how much is C? C is 3 into 10 to the power 8. How much is d lambda? I said 1 angstrom unit. And how much is my lambda? It is 6000 angstrom unit. So this is simple calculation. So 3 into 10 to the power 8 divided by 6000. So if you simplify this, you will be able to get the answer. This is 3 by 6. Okay, 6 5s are 30. So we can say 5 into 10 to the power 4. Angstrom obviously gets cancelled. So Cs, where the value will be in meters per second. So this is the answer. And in this case, we can say that it is moving away from the earth. So we can say away from the earth. So this is the motion or the sense of the motion. Okay. Now we'll move to the question number 6. Question number 6 is very interesting one. Doppler effect has begun now. A railway engine blowing a whistle of frequency 945 hertz. So which means n is given to you 945 hertz is moving with a velocity of 54 kilometers per hour. So we can say 54 kilometers per hour towards a hill from which a sharp echo is heard. So first of all, the train is moving, okay, towards a hill by blowing a frequency, blowing a whistle of frequency 945 hertz, okay, and the echo is coming back. Sharp echo is heard by the driver who is driving this train. So we need to check the frequency of the echo. So in this case, very interestingly, the formula we'll have to use, we need to find out n dash. So n dash in this case, the formula we'll have to use is C plus CL divided by C minus CS into N. Fine. Now the first job, what is the C given to you? C is given 330 meters per second. Okay, now how much is N? N is 945. Okay, N dash we need to find. How much is CL or CS? Okay, the first thing they say that it is moving with 54 kilometers per hour and the echo also is coming at the same speed. Fine. So therefore we'll convert that 54 kilometers per hour in terms of meters per second. Okay, so if you convert that, we will get the value. Try to check the value, that is around 15. Okay, 15 meters per second. 15 meters per second. This. So this is my CS or CL. Fine. So therefore N dash will be 330, which is given to you, plus 15 divided by 330 minus 15 into 945. Okay, so we get N dash is equal to 345 divided by 315 into 945. So if you simplify this, you will get the answer to be 1034.99 or approximately 1035 hertz. So in this case, you will come to know N is 945. So you say N dash is greater than N. When the source and the listener are moving towards each other, the formula is given by this. And obviously the value of N dash, the apparent frequency, is greater than the original frequency. That's what is the problem. Okay. Next question. The two trains are approaching each other with speeds 60 km per hour and 45 km per hour. Okay. So we say train 1 60 km per hour, we have to convert in meters per second, and second one is 45 km per hour, we have to convert in meters per second. A whistle of frequency 512, so N is given out to be 512 hertz, is sounded by the first train. Calculate the frequency of the note heard by the listener in the second train before and after the train pass each other. Okay, so first job we'll do is 60 km, we convert it into meters per second. So 6 to 10 to the power 3 divided by 60 into 60. Okay, so that gives you 16.67 meters per second, and for this one it is coming out to be 12.5. Okay, so what is the formula? The train 1 and train 2 are approaching each other. Okay, so here we have to use the formula N dash, the apparent frequency we need to find, is C plus CL divided by C minus CS into N. Fine. N dash we need to find. How much is C given to you? Is 332 meters per second. How much is CL? CL is for the second train, so 12.5. How much is CS? CS is 16.67. So this is my CS, this is my CL. Just put the values over here. So we get 332 plus 12.5 divided by 332 minus 16.67, okay, multiplied by 512. Okay, so if you simplify this, we get N dash is equal to 344.5, okay, divided by 315.33 into 512, which gives me the answer 559.3 hertz. So this is the answer for the before. Okay, heard by the listener in the second train before they are approaching each other. So in this case, what I got? N dash was greater than N. N was how much? 512. N dash is how much? 559. Okay, this is part E. Now what is the part B to say? They say after the train pass each other. So after the train pass each other means formula will become C minus CL, sign will change, divided by C plus CS into N. So in this case, what should happen? Basically, the value of n dash should be less than n. That's the first thing should happen. Okay, that this we have done in theory also. So now what is the, just substitute the values and we should get the answer. So n dash will be 332 minus CL. CL is how much? 12.5 divided by 332 plus CS. How much is CS? CS is 16.67 into 512. Okay, so if you simplify this, we will get the answer to be 469.16 hertz. Okay, so here n dash, as I mentioned, n dash has to be less than n. Yes, we got the value 469.16 hertz. So this is the way we should solve such problems. Okay, now we'll move to the next question. Question number 8 in the book. There is a very serious mistake, so I don't think I should be taking it and confuse you more. We'll directly move to question number 9 then. Next question. A spectral line of wavelength 5890 angstrom unit. So lambda is given out over here. In the spectrum of star is found to be displayed by 1.178 angstrom unit. So here the d lambda is 1.178 angstrom unit. From its normal position towards the red end of the spectrum, determine the velocity of the star and the sense of motion or the direction. Okay, so as usual, the formula which we'll use is CS is equal to CD lambda divided by lambda. Fine. So earlier I mentioned you how you got this formula. So what is the value of C? We have got 3 into 10 to the power 8 is the value of C. Then d lambda is only 1.178 angstrom unit divided by lambda is 5890 angstrom unit. So if you simplify this, you get the answer to be 6 into 10 to the power 4 meters per second. This is the value of CS, or the velocity of the star. And the direction, if at all you ask, it should be towards the earth. Towards the earth. Fine. Next question. Question number 10. Here, what is happening? A railway engine blowing a whistle of frequency. So N is given to you. It is 960 hertz. And a listener are moving with velocities 10 meters per second and 2 meters per second towards each other. So this is my source and this is the listener. They are moving towards each other. Fine. The speed of sound in air is 330 meters per second. Determine the apparent frequency. So we need to find out n dash. So formula we'll use is n dash is equal to C plus CL divided by C minus CS into N. Fine. So what is the value of C given to you? It is 330. So we'll say 330 plus 2. 2 is for the listener. Okay. Divided by 330 minus 10. It is for the railway engine into N is 960. Okay. So this gives me how much? 332 divided by 320, okay, into 960. So if you simplify this, you get the answer to be 996 hertz. N dash turned out to be 996. So here also we, as I mentioned, n dash value is greater than n. That's what we have seen in the theory also. Okay. Now the next question. Next question says a source and listener move away from each other. Source and listener move away from each other with speeds 15 meters per second each. Okay, both have got the speed 16. So CS also 15 meters per second and CL also 15 meters per second. But CS direction is opposite, so we'll take this minus. Okay, L is okay. fine, with respect to ground when there was no wind. If the apparent frequency heard, so in this case apparent is given to you to be 500 hertz and they are asked is n. N is asked. So what is the formula basically? N dash is C minus CL divided by C plus CS into N. This would have been the formula. Fine. But N dash is given to you, we need to find out N. So the formula will change to what now? So therefore formula will be N is equal to C plus CS upon C minus CL into N dash. Fine. So we can say therefore N is equal to, how much is the value of C? Okay, if it is not given, we'll take it 340. Okay, so we'll take it 340 meters per second minus 15 C plus what I said, yeah, N is equal to C plus CS, but CS is minus value, so that's why minus 15 divided by 340 plus 15 into N dash. N dash, what I said, is 500. Okay, so if you simplify this, you get the answer 325 divided by 355 into 500. So if you simplify this, we get the answer to be around 458 hertz. Okay, so N dash was 500, N is 458. So we can say N dash is greater than N. N dash was given to you, which was 500, N was 458. Okay, but moment I say source is opposite, we have to take the minus sign, which I'll have to take into account, otherwise the answer will be completely wrong. So if they give this problem and ask 458 or ask this question or ask this value, the value will go wrong if you put a plus sign over here. So this you need to be a little more careful with such questions. Okay, we'll move to question number 12. Question number 12, a spectral line normally at 4000 angstrom unit is shifted to 3999 angstrom unit by relative motion of source. What is the velocity of source along the line of sight? Okay, so in this case we'll need to use the formula called as Doppler shift formula. Doppler shift formula. Now what is this formula given by? V is equal to C into delta lambda by lambda. We need to find out what basically velocity of source. So we need to find out how much is C given to you, 3 into 10 to the power 8. How much is delta lambda? Is 1 angstrom unit. Okay, 4000 minus 3999 will be 1 angstrom unit, divided by lambda will be 3999. Yeah, normally at 4000 is shifted to 3999. Okay, so we'll use the value 3999 angstrom unit and simplify this, okay, to get the answer to be 7.5 into 10 to the power 4 meters per second. Check it out. Okay, this is almost 3 by 4. Fine. Next question is question number 13. Question number 13 says, suppose a spectral line of hydrogen normally at 500 nanometer. Okay, so lambda is 500 nanometer is observed in the spectrum of a star to be 500.1 nanometer. So we can say delta lambda is equal to 500.1 minus 500. So this gives you 0.1. Okay, so delta lambda is 0.1 nanometers. Okay, how far is the star moving towards or away from Earth? Okay, so here we'll use the same formula what I use here. So V is equal to C delta lambda by lambda. So this is 3 into 10 to the power 8 into delta lambda to be 0.1 nanometers divided by lambda is 500 nanometers. So don't have to bother for the unit and just simplify this. We get the value to be 3 into 10 to the power 8 into 0.1 upon 500. If you simplify this, you get it around 60,000 meters per second. simplify. Check this out. Okay. Next is the last question. A source of sound moving towards the stationary observer. So here the source is moving and the observer is stationary. So we can say CO is 0. Okay. Moving towards the stationary observer at 20 meters per second. So you have been given the CS. CS is 20 meters per second. The frequency of the source of sound is 380 Hertz. So N is also given to you. It is 380 Hertz. The speed of sound wave in air is 400 meters per second. So which is C is given to be 400 meters per second. What is the frequency of the sound waves heard by the observer? Okay. So you have to use the formula given by N dash is equal to C upon C minus CS into N. Right? So over here, how much is C given to you? It is 400. How much is C? 400. How much is CS? Is 20. And how much is N? It is 380. Okay. So this gives me 400 divided by 380 into 380, which gets cancelled. So answer comes out to be 400 Hertz. Right? So how much was my N? N was 380 and N dash is 400. So we can say N dash is greater than N. So like that we have solved many problems, but this is also one of the problem of that sort. Okay. So this completes all the unsolved problem from the book of the last chapter of this course. Okay, paper 1. Clear? So compared to the last semester's MMP, this is little vast, I will say. So practice it. Okay. I will do the MCQ video only if people are interested. People are watching the videos and appreciating it, then only I'll be able to take the efforts. Otherwise I will not take it. Okay. No issues then. Otherwise, any difficulty, feel free to ask. Okay. And then do well. Thank you very much. All the best for your examination. Okay. Thank you.